edition of Catalysts, a platform for the scientific community to connect, discover, and transform. This is your host, Kedar Aras, and today it's my pleasure to connect with our next guest, Dr. Chris Butson. Dr. Butson is an associate professor in the Department of Biomedical Engineering and in the Scientific Computing and Imaging Institute at University of Utah. Dr. Butson's research focuses on neuromodulation therapy, specifically therapeutic and diagnostic deep brain stimulation, cortical stimulation, and transcranial magnetic stimulation. Using patient-specific computer models combined with tools to enhance brain mapping, Dr. Butson's team aims to predict stimulation locations that can reduce seizures, which could eventually lead to targeted stimulation therapy in future patients. Dr. Butson, welcome to the Catalyst podcast. To begin with, can you share with us listeners how you made the transition from grad school? I understand you did your PhD at University of Utah, and can you share with us what the transition was like from your point of view?
So the transition from grad school to postdoctoral fellowship, because I really wanted to stay in academia. In fact, that was a major motivating factor for me to leave industry. When I was working in industry before doing my second round of grad school in biomedical engineering, I had a great job. It was a great experience, and I could have had a pretty comfortable life just staying there. Mm-hmm. And I chose to give that up and to go back to grad school and get a PhD in biomedical engineering. And I think it's important to explain my motivation. So my motivation was I really wanted to do human subjects research, and I really wanted to help people. I wasn't sure how at the time, but I knew that's what I wanted to do, and I thought that bioengineering was the best way to do that. So I kind of, I gave that up. I came to grad school. I had a great experience in grad school, academically and otherwise. I think if you love the outdoors, then there's potentially a lot of distractions in Utah, and so my experience might have taken a little longer than it could have otherwise. But yeah, it was a great experience, but I didn't really do anything in the way of human subjects research when I was in Utah, which is not it's not a regret at all. It's just kind of the way it worked out. But I did learn a lot of really important skills in computational neuroscience, in simulation, modeling, and visualization. And part of my grad school experience was here at the Scientific Computing and Imaging Institute. And so I really benefited from the model that they have here for students, which is they have these as these big rooms of students, and they take students from wildly different places and they just put them all together.
Right.
And I really benefited from that. I mean, I got to know a lot of people I probably never would have known otherwise, and I learned a lot of skills from them, and I hope they learned from me too.
Right.
In ways that wouldn't have happened. So that was really just, it was a great environment. And then as I was kind of wrapping up, I think I wasn't sure what I was going to do next. But I started looking at postdocs, and I interviewed at a couple of places. And, as you probably know, academia is not so different from industry in that a lot happens through professional networking. Mm-hmm. I mean, certainly there are just kind of, blind applications where there's a position posted on a website and somebody applies, and then, that happens. But I think human nature is such that people have a higher comfort level if there's some trust relationship involved, even indirectly, right? So I benefited from that. Certainly, my mentors here in Utah in ski and bioengineering through their connections, they helped me kind of expand my professional network and learn about opportunities. So I interviewed for a postdoc at UCSD, and that was, really interesting and exciting. I also had kind of a chance meeting with an investigator named Cameron McIntyre, who actually interviewed at Utah for a faculty position. And, often they'll ask groups of students to meet with faculty candidates or whoever comes to campus.
Right.
Okay, so me and some other students ended up taking Cameron to lunch. And Cameron and I really hit it off, and he said he was starting up a lab, and obviously he was thinking about coming to Utah. And so Cameron ended up going to the Cleveland Clinic. And then, over a period of time, I decided I was going to do a postdoc with Cameron at the Cleveland Clinic. And I think there are many reasons for going there. Obviously, one of them was just kind of the stature and reputation of the Cleveland Clinic as a hospital and as an academic medical center. And they're very well known, obviously in many areas, probably primarily in cardiac disease and cardiac treatment. But they're a little unusual in that for an academic hospital, they actually have a true biomedical engineering department. Even though the Cleveland Clinic itself has not traditionally been a degree-granting institution.
Right.
So, students might come from Case and they get their degrees from Case, even though the Cleveland Clinic has a biomedical engineering department. So that was really attractive because being a biomedical engineer who is in a clinical department can be good. I mean, I went on and did that in my first faculty position. But these days, it's a little more difficult, and I'll explain why, in a few minutes.
Right.
But I want to emphasize going to the Cleveland Clinic. I mean, this just happened by random chance, and many of the good experiences that I've had in many ways in academia have come about by random chance. And my role in it was to be open to random chance when it happened.
That is interesting, yeah.
And I'll explain a little bit more about that as well. So I went to the Cleveland Clinic, and I really wanted to do human subjects research, and I really wanted to do therapeutic research, and this gave me that opportunity. So I began doing research on deep brain stimulation for movement disorders such as Parkinson's disease.
So that was your postdoc directly?
Yes.
Okay.
And this was, it was a great environment for that. I had a great mentor. I got to work with a lot of really talented people. I was in the hospital. I could walk over to neurology and neurosurgery whenever I wanted to. It was a great environment. I really learned a lot. It was also, highly productive. And I benefited from good mentorship from many people. And, and one thing that they kind of made clear to me pretty quickly was, you're on the academic track. You want to be on the academic track. So when you're thinking about a postdoc, on your first day of your postdoc, you have to start thinking about what's coming next. Because postdoc, you're in limbo.
Right.
It's not, it's not a permanent position. And quite honestly, if you're in a postdoc for a long period of time, it can almost be cause for concern, right? It's meant to be a temporary position. So people emphasize to me, you need to start thinking about, what comes next.
Right.
Okay. And they also helped me begin writing my own grant applications.
That's amazing. Yeah.
And that was very valuable for obvious reasons, but also for indirect reasons. And I tell my students this too. So, obviously, if you write a grant application and you're successful, you get the money.
Right.
And then you get to do the research.
Right.
And I think, in a good postdoc, you have the most intellectual freedom and the least responsibility you will ever have in your entire career, right? So I think for a lot of faculty, we spend the rest of our lives trying to get back to that state that we were in as a postdoc.
Got it.
So it's, and if on top of that, so a good postdoc will just give, they'll give you a lot of freedom. They'll have expectations of you, but they realize, this is your time to build up your research program and to be competitive for a faculty member, for a faculty job if that's what you want. And so certainly, that was a really strong element of it. But there's many indirect benefits from getting your own grant application. And it doesn't even matter how much it is. I'm not talking about an R01.
Right.
I'm talking about I had, and I think the mechanism was an F32.
Right, the postdoctoral fellowship.
Yeah, it's a small amount of money, but it pays most of your stipend, and it gives you a budget. Back when I got it, I had my own budget of about $6,000 a year that I could spend, and I did spend mostly on travel to conferences and on computing equipment. Great. I mean, it's fantastic, but it's also fantastic for some indirect reasons.
Right.
One of them is you are the PI on a grant that you got, and that's on your CV before you start applying for faculty positions.
Right.
That's huge. Another indirect benefit is the act of writing a grant forces you to organize your thinking. And plan out and think through the experiments you're going to do, and then think through the outcomes, and then think through, how do I design this project so it has the highest possible likelihood of success.
Right.
And I think that's honestly, even though that's not a formal review criteria from NIH, I think that's one thing that all of the reviewers have at the forefront of their mind.
Right.
They don't want to take risks when they're giving away money.
Right.
They want to give money to projects that have a very high likelihood of success. Yeah. So I was able to get my own grant, an F32. That gave me a lot of freedom. At the end of 2 years, things were really going strong. I mean, we were just cranking out publications, and I didn't want to give it up. I didn't want to leave then, and they didn't want me to leave. And so they kind of persuaded me to stay for another 2 years by making me a staff scientist.
Oh, wow. Okay.
So a staff scientist is also a limbo position, right? It's not meant to be a permanent position,
right?
And you don't have a lot of long-term job stability, but it does show that you were promoted. You're no longer, a postdoc. You're no longer. You've sort of graduated from being a trainee.
Right.
Okay,
right.
so that's conceptually important. And I got a big raise.
Right.
Okay, so that was also important. So I stayed around for 2 more years, and during that time, I started interviewing for faculty positions.
Got it.
So there's also something really important that I should point out, and.
Right.
And this may be obvious, but I'll say it anyway. So anybody who goes into academia, I would argue, is strongly motivated by their intellectual curiosity, right? Nobody goes into research for the money.
Right.
You could make far more money in many other fields, and if you just wanted to make a lot of money, then I don't know, you would end up doing something else.
Right.
So. And people who go into research, I mean, I think they kind of have what I call the research bug. And if you have the research bug, then there's really not many other jobs that are going to satisfy it.
Right.
And I think that some people end up in research almost by process of elimination, right? They're virtually unsuitable for any other kind of work, so then they just end up in research.
Yeah.
So it's really important to point out just that I often tell people who young students, we happen to know. I happen to know a bunch of students now who are seniors in high school, and they're thinking about going into engineering. And going into engineering can be appealing for many reasons, I guess.
Right.
And, you can have a good income and a stable life and all these kinds of things. But the thing I tell them is, you have to love it.
Right.
And the people who I knew who didn't love it, they didn't make it.
Right.
It wasn't because they weren't smart enough. It's just, it takes that level of kind of
commitment and passion.
Yeah, absolutely. And so, and doing research is the same way. As a researcher, there's no limit to how much effort you can put into your job.
Right.
In terms of, trying to be kind of as productive as you want to be.
Right.
There's no upper limit on it.
Got it.
But this is also, it's important when you're applying for faculty positions. So applying for faculty positions is a complex process for many reasons. One of them is, some of them are obvious. Faculty positions are incredibly competitive, and you're getting evaluated on many criteria.
Right.
And no matter what institution you're applying for, people have different agendas about who they want to hire.
Right.
Well, I think everybody wants to hire new faculty in their subfield, right? But even when I was applying for faculty positions, even when I knew I had good friends who were at institutions and they were sort of on the inside, it didn't really help. And I think I don't mean to say, I was expecting special favors because I knew these people. I wasn't, and it shouldn't work that way, right? It should be like a quasi-democratic process, and they should really hire the best candidates. But even when I knew people on the inside, it didn't help me understand their process. And so, I think in many areas of science, we aspire to have kind of an egoless approach. Just put your ego aside. And so, applying for faculty positions is certainly like that. Just put your ego aside. Just send out lots of applications.
Right.
Talk to lots of people. Go to as many meetings as you can.
And you mean conferences?
Conferences, yeah. Just expand your professional network. I mean, that is, especially in your last couple of years of grad school, do whatever you can to attend as many meetings as possible, and just get out there and meet people. And with the students in my lab, I try to help them do that, a couple of ways. I mean, I tell students that if they're productive, then I'll pay for them to go to, on average, one conference a year.
Right.
But they can go to a lot more than that. I mean, so I often encourage my students to apply for travel grants. And I would say their success rate at doing that has been over 50%, which I think is
pretty impressive.
Is very good.
Yeah.
And I mean, they put a lot of work into it, but like it paid off.
Right.
And so my students easily have doubled the number of conferences that they've been able to attend, and I think they've been able to expand their professional network just by just
being
getting
there
out there,
and meeting people.
Right. So I think that's during the transition period, that's really important. And the other thing that's really important is when you're when you defend your dissertation, this is your kind of your, I don't know what to call it. It's your initial act as an independent scientist. Right. And then, you just need to keep kind of polishing that and coming up with a research plan and being, a really, really effective communicator. And this is another indirect benefit of going to a lot of conferences. I have my students get up and present just as often as possible. And honestly, that was also a huge benefit to being not just at the Cleveland Clinic, but in Cleveland. So Cleveland has a lot of different research organizations scattered around the city. There's Cleveland Clinic, there's Case Western, there's Cleveland State, there's the VA, and then there's sort of all of these, I don't know what to call it, if there's centers or institutes or consortiums, but there's all these groups of people that collaborate.
Right.
And they have all of these mini conferences that, people outside Cleveland, I don't even know if they know about them. So when I was at the Cleveland Clinic, I mean, I went to every single little meeting or conference I could. These were tiny meetings, these were sometimes a conference room full of people, but, I got up and I presented. And I kept doing it as often as I could. I would just get up and present and just keep practicing and practicing and practicing.
Right.
And, practicing communication is something that, that's a lifelong activity. It's just like, it's like being a professional athlete. You don't become a professional athlete and then quit practicing, right? You keep practicing as much as you ever did. But that's also, I think, a really important part of that transition period. When you're a postdoc and you sort of have that time, just get up and present as often as you possibly can. And, keep formulating your ideas and presenting it to other people, and then hopefully kind of focusing your message more based on the feedback that you get from people.
Got it. So what I'm hearing is once you transition from grad school into postdoc, that is probably one of the best periods of your life when it comes to freedom to do the research you want to do. And rather than waste that time, you gotta leverage that time to meet as many people as you can, hone your communication skills by giving presentations to as few or as many people are in the room.
Yeah. And
just get the funding and get skilled in grant writing. And realize that it's a process which is a hit and miss, but still the whole process of doing it helps you focus your ideas, what you want to do, and then build on that.
Yeah.
So then transitioning from postdoc into staff scientist and eventually applying for assistant professors positions, I imagine the positions that you encountered to apply for came through direct contact with people who you met and they said, hey, there might be a position here, why didn't you apply, and something like that. So the question then becomes is, how was that? I understand the whole interviewing process is a two-part process. You have a job talk and then you have a chalk talk. So the job talk, as I understand it, is you just give a presentation like a seminar, and then a chalk talk is in private with the faculty, where they kind of ask you questions about your research, your future plans, and some more detailed, inquisitive questions, I guess, about your research. So I was wondering if you went through that process, probably more than one time as you applied to multiple positions, and how was that experience like? And what were some of the things you encountered in terms of questions that you may not have kind of thought they would ask? Because one question that one of the professors I interviewed and who went through this process shared with us was, during the chalk talk, the one question that invariably gets asked is, how is your research going to be different from your PI who you worked with for your PhD and
Sure.
the PI you worked with at the postdoc level? How is your research going to be different from those two? So that is a pretty interesting question, and it helps when you can carve out your niche, which is different from your mentors. So I was wondering, was there something you found out that would be helpful for the listeners when they go through this process?
Yeah, so, giving the job talk, I think certainly there's a lot of focus on that, right? And it's not so different from giving any kind of hour-long seminar, right? It's just, it has a little more formal feel to it, because you're really interviewing for a job, because it's on top of the science that you're presenting.
Right.
And so that's not so different. The chalk talks, those feel sort of new to me, in the last few years, because when I interviewed for assistant professor positions in 2007, 2008, I don't really remember doing these chalk talks.
Okay.
I mean, people still just asked whatever they wanted to ask, but it just wasn't kind of in an organized group fashion. And then when I was interviewing most recently, this year here at Utah and other places, so there were two places that really wanted to do these chalk talks, and they get to ask whatever they want. And I quite honestly, I'm not sure how well developed an idea this is, because after doing the chalk talk, I didn't personally feel like it was a very satisfying or compelling experience. I mean, it wasn't bad, but it wasn't that great either. And the people I talked to, so in both the cases that I'm thinking of, there are people in the audience who I knew pretty well. And so I just asked them, and they sort of conveyed the same thing, that it wasn't bad, but it didn't really add anything. And as the person who was standing up there, I never could get a clear sense of what they were hoping to achieve.
Right.
And I even asked them this. So I said, so if the Chalk Talk is really successful, whatever that means,
right.
What happens? And I could just never really get a clear answer. So quite honestly, I'm not sure what institutions are hoping to achieve by having these Chalk Talks. And maybe it's just because, I haven't been to that many of them as a presenter or an audience member. But I think having Chalk Talks, I think it's a good idea, but my impression is it's also kind of a work in progress, simply because I haven't yet met anyone who could really articulate, what is a fantastic Chalk Talk?
Right.
What does it achieve?
Right.
So in the interview process, I guess probably what they're looking for is something that is maybe just an extension of the formal job talk, which is, can you stand on your feet and basically respond in real time to questions, which is a different experience than having as much time as you want to prepare a 1 hour talk, where there's very confined time for questions, and you more or less have complete control over the course of it.
Right.
So maybe I guess that's an important part of it.
Got it. And in your opinion, how much does having your own funding help make your resume attractive, and how much does the pedigree you come from and the lab you come from help you, and how much does your publications help you? And then you have the intangibles of how you gave your talk, and the communication skills, and how you come across, and the chemistry you have, and so on and so forth. So if you had to rate in terms of the top 3 attributes.
Yeah, that's kind of hard to do. You mean when you're applying for faculty positions?
Faculty positions, yeah.
Right. Honestly, I don't know of any place that really expects assistant professor or faculty candidates to already have their own funding. Clearly, if you do, that's fantastic, and that's just a huge plus in your favor. But I don't know of anywhere that really expects that, nor do I recall seeing job descriptions that said, you really need to have your own funding. And there's practical reasons for that too that may not be obvious. So if you were a postdoc and you got your own funding,
right.
Well, it would be highly unusual, I think, for a postdoc to get an R01 or an R21.
Right. Do you require faculty positions to even apply for an R01?
Yeah, and so, but the converse of that is that I think, so in my case, I did get a training grant.
Okay.
And there's all kinds of different F and K awards that are available to people who are kind of, in postdoc fellowship or early faculty positions. However, many of those awards are tied to the institution, right? So even if you get one,
right.
if you leave and go get a faculty position, the grant doesn't go with you.
Got it.
So I think this is a combination of external factors where, funding expectations this is my impression, are not that high for postdocs. Clearly, publications are really, really important. During your postdoc, where you have kind of maximum freedom, and you should really just be cranking out papers, the best papers you can, and really trying to achieve impact. Now, that's very elusive, right? So, many people have tried to explain the trade-off between a lot of papers in low-impact journals versus a few papers in high-impact journals.
Yeah.
Okay, so, people can debate about that. But the reality is that if your postdoc is let's say 2 years, even if let's suppose that you got a paper accepted in your first 6 months of a postdoc, which I think would be just going gangbusters.
Right.
Within that 6-month time point and the time you're going to start applying to faculty positions, the impact of that paper is really going to be unknown.
Mm-hmm.
It takes years to know kind of what the impact of that paper is.
Right.
I mean, if it's a Nature paper, that's something different. But
Right.
but it's very hard to know what the impact is going to be. And so then you're also in a position of trying to kind of convince people about the potential impact of your research, because it's just not going to be truly measurable in that time period.
Mm-hmm.
And the other thing you asked about pedigree, I think pedigree is really important. And in science, I think we aspire to be very egoless and kind of have this very egalitarian approach.
Right.
But there's some element of human nature involved. And the opportunities that become available to you
Mm-hmm.
are almost certainly influenced by who you trained with.
Right.
Either because of people's perceptions about your mentor or because of their professional network or any number of reasons. And
Right.
so that's one of those things, in an ideal world it probably shouldn't matter,
Right.
but I think it does.
Got it. And then those communication skills are required regardless of whether you're in academia or in the industry. Any place you are essentially marketing yourself, your skills and talents, and that means you need to have extremely good communication skill. So that's a given, I imagine.
Yeah, and I think also being able to understand who's in the audience,
Mm-hmm.
and then customizing your talk to who's in the audience. So my work is heavily translational, and sometimes there's all computer scientists in the audience, or all engineers, or all neurologists or neurosurgeons,
Mm-hmm.
or and so I try to give very different talks that are kind of customized to that audience. And then sometimes it's just a broad scientific audience, and quite honestly, those can be
Right.
most challenging.
Right.
You're trying to reach as many people as you can, and get people excited about what you're doing, but at the same time you don't want to bore people who have a lot of knowledge in that field already.
Right.
So that's a major challenge. But fortunately, I don't think that happens too much in the hiring process, right?
Yeah.
I mean, I think that happens later in your career.
Yeah, got it. So segueing a little into the research building portfolio, or building a research portfolio phase, did you always have this interest in neuromodulation therapy right out of grad school, or was that something you picked up along the postdoc state and kind of fleshed it out and then made that your niche moving forward?
Yeah, so it's hard to describe that process. I mean, I was motivated by something, even though for a long time I couldn't quite articulate what it was. So first I just wanted to, do human subjects research and help people. And then, when I started doing that, I realized, well, I already have 2 degrees in engineering, electrical and mechanical, and I'm
Right.
really kind of drawn towards kind of electromechanical systems. And I'm also drawn towards using computational modeling to generate new insights. I mean, that was something that felt very, it felt like a very productive approach to me. And I knew, I was also drawn towards neurological illnesses and, and better understanding the brain.
Mm-hmm.
And so these were all things that were sort of innate. And I was kind of going through my own discovery process about, what were the things that really interested me and how do they all converge. And so I think with studying neuromodulation therapy, this is kind of the convergence of all of these things. And in fact, it's what we do in my lab. Computational modeling, human experiments, and, and putting all of this together to try to generate new insights and new therapies to help people.
Got it. Okay. So building your research portfolio, how much is it mostly organic based on the research you already do and you kind of build upon that based on new research data you collect that fuels more research questions? And how much is it through collaboration where people you meet, kind of the collaboration and the synergy kind of creates new ideas and questions, and how much of that is really a factor, and what's your philosophy behind actively seeking out collaborations to help build a portfolio, and how much it is just random or happenstance?
Yeah, so that's kind of an evolving process. I think when you're, a young faculty member, you do have to do a lot of legwork, to build up collaborations. But this is particularly in bioengineering, where collaborations, clinical engineering collaborations are viewed as, a major achievement and something very desirable as being a necessary step for translational research, right?
Right.
So, and it's probably different in a little bit different in other fields, but collaborations are just I think the lifeblood of bioengineering. And yeah, so as a young faculty, you have to keep going to meetings and just keep expanding your network and talking to people and keep being open to new collaborations. So I think the approach that I've followed that's worked out, I've been pretty happy with how it's worked out, is we've developed kind of discrete technologies. And then we'll try to figure out, how they might be used, and we'll show them to people, and we'll adapt them, and we'll kind of play around with them, and we'll plan, small experiments. Again, I've had the benefit of working in places where I had immediate access to clinicians. So when I was in Wisconsin, I was at a medical school, so they don't have an engineering department. I mean, I was appointed in 3 clinical departments: neurology, neurosurgery, and psychiatry. So I had very easy access to all of these people. So it was very easy for me to interact with them because I would just run into them at the coffee machine and we would chat for 5 or 10 minutes. And these kind of more frequent interactions, they just wouldn't happen if I had to set up a quote-unquote meeting with them, every single time.
Right.
Because then we have to find their assistant and look at their calendar, and and they'll say, oh, well, yeah, in 2 weeks I can meet with you.
Got it.
So a lot of just kind of informal, running into people, developing ideas, listening to them and what they found interesting. And so what we would try to do was just build discrete technologies and build ones that my clinical collaborators and colleagues were interested in, and then just let things grow, organically from there. And that's worked pretty well. And now, after a period of doing that for a few years, I have new colleagues who are contacting me,
right?
Because they want to collaborate and they want to work on these things. And it's really, it's a very, very difficult balance to achieve in terms of time management, because not all collaborations work out for all kinds of reasons.
Right.
And time management is probably the biggest challenge of being a faculty member. So you don't want to put a lot of time into collaborations that ultimately are not going to be fruitful. Right. But it's very difficult to predict that up front. So you're kind of going through this continuous process of how do we pull this off? Right. So my approach to that is, if I sit down with a potential new collaborator, if it seems like we both have a gut feeling that something good might come out of this collaboration, then I say, okay, let's do this. Let's design an experiment that we think we could conduct in an afternoon, right? Keep it small and discrete and simple. Right. Because if we think we can do it in an afternoon, it's probably going to take about 6 months. But if it's so small and simple that we think we can do it in an afternoon, and we actually pull it off, well then, if we can get over that initial hump, then things just have a tendency to just grow organically from there. Right. And I think that's been a pretty successful strategy. And And, in terms of who to collaborate with, it's very, very unpredictable. These days, I would say about 75% of my collaborators are physicians, and 25% are engineers.
Right.
I think that's probably unusual for an engineering faculty member, but that's just kind of the way it's worked out. Since I got to Utah, I just by chance at a party met a mathematician, and so he and I now are kind of exploring, doing a collaboration and trying to find a common language to speak, to understand a good problem that we're both interested in, and then trying to understand what might come out of this. And so, but this is just random.
Got it.
Random chance, and it's very hard to predict.
Right.
Go ahead.
Yeah, but it's interesting. You mentioned something which I find very interesting. It's that when you start a collaboration and you're not sure where it's going to go, oftentimes try for small successes, like a proof of concept, and see if that is even viable. And then if it happens, like you said, an afternoon experiment, then you have something to kind of build on, and that eventually might end up being a more fruitful collaboration as opposed to just trying to shoot for the stars without really thinking through the whole process, I guess.
Yeah. It's a kind of a tough balance to achieve. By virtue of being in research, we should be studying problems that have not been studied before, or there's no solution. Right. So you really do want to kind of shoot for the stars.
Okay.
But at the same time, there's the practical reality that the currency in research is grants and papers.
Right.
And you better be
practical
getting grants and papers just continuously. And so, it's hard to achieve that balance where we are really just, thinking up some crazy new idea and just, really shooting for the stars, but at the same time saying, okay, that's our long-term goal. Let's set a shorter-term goal, which is to get a manuscript and a grant application.
Right.
And so, try to think out some incremental step to shooting for the stars.
Right.
That we think, oh yeah, this could be a publishable unit, and that could be preliminary data for a grant. And then if we can get that grant, we can publish, more and keep making these steps. And there's always risk involved. Sometimes the collaborations don't work out. Sometimes the science doesn't work out. So it's very, very difficult to predict
how it's gonna fall out.
Yeah.
Speaking of grants, how much time do you spend out of your research time writing grants? And what does it take to write a successful grant based on certain common do's and don'ts?
Right. So the easier question is, how much time do I spend on grants? I would say I probably spend, in terms of writing grants and kind of managing the grants that I have, that's probably about 40% of my total effort.
Wow. Okay.
So, and those are different types of things. Writing a grant is kind of a creative exercise. Managing a grant is more kind of, administrative, making sure the science is on track, making sure that all the people who are working on the grant have all the resources they need to actually do it.
Right.
In terms of writing successful grants, I don't know any oracle of grants writing. I wish that I did. My experience has been that the goal of grant writing is to achieve reviewer enthusiasm, which is a very elusive concept. But when you achieve it, it's quite obvious in the reviews. And when you don't achieve it, the reviewers will often just sort of just pick away at your grant at things that, maybe matter, but often it just doesn't seem to be a big deal. And it's just sort of like, why are they picking away at all these small issues? And so when I get reviews where the reviewers are kind of just picking away at a bunch of small issues, my interpretation is, it's not really the small issues. They just weren't enthusiastic about the idea at the outset. So I'm trying to achieve reviewer enthusiasm.
Got it.
That's very difficult to define or achieve. My experience doing that is to make grants absolutely as simple as possible. When I've written grants that are very technical and complex, often, more than half the reviewers just don't understand. And most reviewers are smart people. It's not that they don't have the capacity to understand. It's probably just more a practical aspect, which is, I'm on NIH study sections and even training grants. Training grants, the science portion that's written by the applicant is 6 pages long. The entire grant application that I have to read is usually, 100 to 150 pages long.
Wow. Okay.
So, 10 to 20 times longer than the science
Actual
portion.
Science, yeah.
Ideally, I should really just be focused on the science, but I do need to read all of the rest of the grant to really understand it. This is incredibly time consuming.
Right.
And often a reviewer will get a whole bunch of these to read. And so, reading grant applications and then evaluating them and scoring them, it takes a lot of effort and concentration, and you can only expect a reviewer to do so much of that.
Right.
That's just the reality. So the most successful grants that I've ever written were the ones where I felt, this is so simple, I can't even believe I'm submitting this. I basically taken a lot of the things that as an engineer I get really excited about because they're really technically complex and I think they're innovative, and I just have to strip that out of my grant and just simplify it to its essence, just make things as clean and simple as possible. And I think when I've done that, that's been the attribute of the most successful grants.
That's interesting because one another thing, and that's similar to what you just said, as keys to writing a successful grant was telling a compelling story, which is similar to keeping it simple and not getting bogged down into the nitty-gritty details, which are important but not enough to get a reviewer enthusiastic about your project. So keep it simple and try to tell a compelling story that gets them all excited about the project or the grant.
Yeah, and I think also, learning to write grants has made me a much better writer. So, so for example, in some of my early grants, so grants these days, you have to follow the NIH format, right? So it's specific aim, significance, innovation, approach.
Right.
And NIH provides guidance on what should be in each of those sections. So in some of my early grants, I noticed that I was kind of saying the same things over and over and over in every section.
Right.
And then I started getting some training in grant writing, like going to grant writing workshops. And then I kind of realized that, if I'm doing that, if I'm saying the same things over and over and over, I'm doing something wrong. And what I was doing wrong was not having a really in-depth understanding of the purpose of each of those sections. And so, this may be easier for other people than it was for me, but I found, to really high quality grants, I could write about a page per day. So that, I always thought it would go faster,
right.
But the reality is that if I wanted, what I consider to be really high quality writing, that's about
a page a day.
What it took
right.
for the whole process, for, writing a draft, refining it, honing down the ideas, exploring right. different approaches. Yeah. So that's a lot of work. And then also paying really close attention to what are the different sections asking for. For example, what's the difference between significance and innovation? Okay, when I started out, I just thought, it sounds pretty similar, right? It's significant, it's innovative, those are almost interchangeable.
Right.
Well, but I learned that they're not in NIH language, and I really had to get an in-depth understanding for myself of what it was they were asking for.
So significance would be clinical significance, and innovation would
Doesn't
be...
have to be clinical.
Oh, it doesn't have to be clinical.
No, it doesn't
Okay.
have to be clinical.
Okay. Got it. Because when I wrote the proposal, I had to follow the NIH format where it was clinical or significance and innovation piece. That's interesting. Okay.
Yeah. So those are kind of subtly different things.
Okay. Well, taking a step back, looking back on your career, is there something you wish, looking back now, you had done more of, or you had done less of?
So I wish that I had engaged less in kind of administrative stuff, because there's, as a faculty member, there's a virtually infinite supply of administrative stuff that, and many things that only take a very short period of time. But if you add them all together, it takes up an incredible amount of time.
Right.
And so one skill that I wish I had learned earlier was just how to just ignore some of that stuff and shed other stuff and just and delegate more of it to other people.
Right.
Because that's kind of a constant battle, figuring out, am I really the only person who can do this? And then, if you're not, well, then investing the time to get it off your plate somehow.
Right.
So, because that takes time too,
Yep.
and you want that time to pay off. In terms of things I wish I had done more of, honestly, the only thing that comes to mind is, I wish I had kind of blocked off more time for writing. So, and done it in a more formal way. So I think if you're in academia, and certainly on the basic science side of things, not the clinical side, clinicians for the most part don't control their schedules anymore.
Right.
I mean, it's just, and that's probably gonna keep happening more and more in the future. If you're in the graduate school or in an engineering or basic science department, in theory you have all this schedule flexibility. Well, so one inadvertent result of that is that, if you look at my schedule, it looks like I just have vast amounts of free time.
Yeah.
But
it's not true.
it's not really free time. I have an incredible amount of work to do, but it's not structured. So I think what I wish I had done in retrospect was kind of schedule in time for the most important things, like writing grants and papers, the same way I schedule in meetings.
Right.
So just putting in, blocks of time on my calendar. I'm setting aside 2 hours or 4 hours, and it's for, writing this
Specific
grant,
task, yeah.
and that's it, and I'm not available. And not so much as a message to other people, also as a message to myself.
Right.
Right? I've set aside this time, and I'm gonna do it. And if I don't do that, it sort of lowers the threshold for getting, distracted or sidetracked onto something else that comes along that kind of feels more urgent.
Got it. That's great advice, because oftentimes when the time isn't structured, you think there is more time than there actually is, and time just slips by, and then you realize there isn't enough time to do all that needs to be done. So the structure is definitely an important element of managing time.
Yeah, and also, it feels sort of antisocial, but it's not. Just, closing my door, closing the blinds, I'm not available.
Right.
And certainly shutting off email,
Yes.
right? And maybe, turning off notifications on my phone too.
Mm-hmm.
These days it's just, there's so many, sort of gadgets and notifications and programs that can intrude on your time in unexpected ways.
Got it. So one final question before we wrap up. 20 years from now, 30 years from now, when you look back on your career and look at everything you accomplished, how would you like to be remembered by your students and by your peers? What would you like your legacy to be?
Sure. So by my students, I want to be remembered as a good mentor, and in that aspect, I mean, I've been pretty happy so far. I mean, my students have consistently given me feedback that I think reflects how I feel about them, which is, my students and trainees, including postdocs, they are my highest priority. Mm-hmm. So they have access to me, 24 hours a day, all year. Now, that doesn't mean that I don't treat them as the independent scientists they are. I'm not holding their hand all the time. Right. But, I'm always available if they need me. They always know where I am. They always know where to find me. And so, doing that alone is not enough to be a good mentor. But I think it's an important part just so that they know kind of where they are in my priority scheme. So I've been pretty happy about how that's gone so far. And I think in the future, I hope that I can maintain that. I mean, in academia, the further you get in your career, mm-hmm. the more responsibilities you get, and it's kind of like eats away at your time for other things. So I hope I'm able to maintain that with my students. So, and then the legacy to leave behind. I mean, my motivation for going into biomedical engineering and then going into clinical and translational research is to help people with neurological illnesses. And, in neuromodulation is also really expanding now into psychiatric illnesses. Mm-hmm. So, when I look back, I want to look back and say that I helped as many people as possible, and that I helped them in ways that probably would not have come about if it were up to just kind of the following the methods of care that are available today, and just making little incremental steps in the methods of care that are available. In neuromodulation, we have a very complex biological system, the brain, that we really don't understand the function of, mm-hmm. and we have very complex stimulation systems, and so we're trying to kind of merge complexity with complexity, right. and do it in a way that people's lives are improved, and that's a very, very difficult process, and I think it's also a process that is unlikely to occur in a purely clinical setting, where so one of the models for medical education is, see one, do one, teach one. Mm-hmm. Okay, and that idea has been around for a long time, and so I think that a lot of people in medicine are strongly influenced by what their mentors did, and so that I think that's a natural consequence of that approach. Right. But there's kind of an implicit consequence, I think, of that approach, which is each place that does training kind of has their own body of collective wisdom that may or may not be documented very well, mm-hmm. either in the literature or otherwise. Right. I don't think that approach is going to work with neuromodulation. It's just too complicated. There's just too many free parameters for any individual or small group of individuals to somehow internalize all this complexity and make sense of it, and then from that, have a lot of predictive power about how to best treat patients in the future. So, I hope that that's kind of my contribution is being able to manage that complexity in such a way that we can have much more predictive power about how to apply therapies and who's going to respond, and as a result, that we improve the lives of a lot more patients than we would have otherwise.
Got it. Well, thank you, Dr. Butson, for your time.
Sure.
And with that, we'll wrap up this edition of Catalyst Podcast. If you liked what you have heard, I encourage you to share this episode with a friend. I'd also love to hear your thoughts on how you are striving to be a catalyst. So I invite you to leave a comment on the Catalyst's website. Thank you for listening, and until next time, connect, discover,